I'm going to do this problem on seatbelts, number 14 from the book, because I want to go over how to use StatCrunch to do this. So I have videos up on how to do the TI and Excel. The lecture notes had how to do it by hand, but the just plain arithmetic of getting it into your calculator for the formulas is very aggravating, and it's definitely one of those problems that you are better off to use technology. In case your Excel or TI doesn't do this for you, I wanted you to have the added option of StatCrunch. So this example here, a study of seatbelt use involving children who were hospitalized after motor vehicle crashes. We have 123 children who were wearing seatbelts. The number of days in ICU was 0.83, with a standard deviation of 1.77. Now we had then 290 children who were not wearing seatbelts. Their number of ICU days was 1.39, with a standard deviation of 3.06, and we can see this is cited. We want to use a 0.05 significance level to test the claim that children wearing seatbelts have a lower mean length stay than those who don't. Okay, so in other words, seatbelts mean that children survive crashes better and with less injuries. So we're going to start with our null and alternative hypotheses. So our null is that there's no difference between whether, so H0 is that the null 1 equals null 2, that there is no difference between these, whereas the second one is that null 1 is less than null 2. And this is seatbelts, this is no seatbelts. And this is one of those things, a lot of times I will actually label it in myself. I might even write this as, seatbelt use is less than non-seatbelt use, something like that. This is ICU length stays. But a lot of times I have it labeled in my notes which one's which, because it's really easy to forget what you called group 1 and what you called group 2. So like over here, I wrote down the numbers, the mean and all that stuff to put into StatCrunch here in a few minutes. And I have mean 1 written up by the seatbelt group and mu2 written down by the non-seatbelt group. That labeling can be, otherwise it's really easy to get it backwards. Now, it's not that big a deal if you get it backwards. It's just your negatives and positives will be reversed and you can get yourself really confused easily. So just labeling matters. That's the point of that. Okay, so I need to now find my test statistic, right? Okay, I need my T statistic. So I'm going to come over to StatCrunch, which I have somewhere here. Okay, so I'm going to go to T-stats, okay, and I'm going to go to toSample, and I have summary. Now, if we had data, we'd use data up here. So if they gave you data, you'd put the data in, you'd use this. But I have summary, so I'm going to put in this. So sample 1, my was 0.83, my standard deviation was 1.77, and I had 123 people. Second one, I had 1.39, not 139. Okay, and then 3.06 and 290. So this is just copied straight from the problem. Okay, now I'm going to leave that there. I'm going to change here, and I want to change. Okay, so now this is where I get, so I'm going to come back here for a minute. So what this is really saying here is then mu1 minus mu2 is less than 0. So I'm saying that this is going to give me a negative result. So is that what I just put in here? Yes. Okay. So you can see that matches the direction, but they're just doing it a little bit different. So these two are the same thing. Okay. Whereas if I did mu1 is greater than mu2, then you can see here that I would end up going the other way here. So that mu1 minus mu2, and then that way I'd have it the opposite. I'd be eating this, it'd be bigger, this would be positive versus negative. So just kind of a heads up there, that's how that works. Now, my confidence, so then I'm going to compute, then my T-stat is right here, this negative 2.33. So T equals negative 2.33, okay? Now, 2 ways I can decide if I reject or fail to reject. So first of all, this gives me my p-value. My p-value is 0.01. The question is that p-value less than the significance level? The significance level is 0.05. 0.01 is smaller, so this would tell me to reject. I can also look up the critical value, and often, remember, I ask you for the critical value, so not a bad idea to do this. Oh, I don't want two sides. Hold on a second. Okay, so to find that, I would come up here, I would go to calculators, T, okay, and my DF here would be, I would use the smaller of them, so 122, because 123 minus, the other one would be 289, and then this would be, let's see here, I would put this in as 0.05, okay, and compute. So I would get negative 1.65, and I'm doing less than, so I would want to know if I'm less than this value, and I am, okay? So either way, I would reject because my negative 2.33 would be down here, right? Okay, so I can either do the critical value method or the p-value method. They will both give me the same results, okay? So that's how to do it in there. So coming back here to my problem, which I lost here somewhere. There we go. Okay, so this says to reject in either case, which means that I am able to prove that they have a lower mean ICU stay if they're wearing seatbelts. Cool. I proved that, right? Now, so is sufficient evidence to support at my 95% the claim that children wearing seatbelts have a lower mean length of stay in ICU than those not wearing seatbelts? Now, what about our confidence interval? So to do a confidence interval, okay, so I'm going to come back here. I'm going to go to, again, same place I was before, put back in these same values. Okay, 0.83, 1.77, 123. This was 1.39. This was 3.06, 290. Come down here to confidence level. Now, this is where this gets tricky. I am doing a one-tailed, which means I have my entire 5% here in this tail, right? Okay, so this is 5%, which means a confidence interval has to be two-tailed, which means I need another 5% over here. So this actually needs to be a 90%. Remember, this was the trick. If you were doing a one-tailed hypothesis test to make the confidence interval match, you double it. Now, if this was two-tailed, I could just use the same, but it's not. So I'm going to do a 90%. So then this here, negative 0.96 to negative 0.163, this is my confidence interval. And so this is saying that negative 1.96 of a day to negative 1.6 day, they are staying that much less than those who aren't wearing seatbelts. So, almost a day less to, just barely. I mean, that's not a huge difference, but still, it's a difference. So this would be my confidence interval right here, depending on what they told me to round to. Okay, hold on a second. Going back to my problem. So construct a confidence level. So there's my confidence interval. And that also then would tell me to reject that, hey, this is always negative. I am seeing a difference. What important conclusion do the results suggest? Well, this suggests that wearing seatbelts shortens ICU stays, which is a good thing. So in other words, wear your seatbelts. Hopefully this helps you learn how to do this in StatCrunch. The method is the same no matter what technology you use, but it's just a matter of which one works for you. So whether you use the TI, you use Excel, or you use this StatCrunch, make sure you know how to do it. I'd focus on one and stick with it. Don't flip-flop between them.